the values we have gotten from this experiment. We want to see how to what? Plot the graphs and answer these questions that follows. Okay? Now, how do we do it? First thing you do before you plot your graph is to write the date of your experiment. Write the date. Now, after writing your date, write the title of the graph. A graph of, they say we are to plot D2 against D1 and also D3 against D1. A graph of D2 or D3 in CM against what? D1 in CM. So we are to plot D2 against D1, we are to plot D3 against D1, still on one graph. There are reasons why this graph plotting is asked to be plotted, and we'll see it. So we label the y-axis to be D2, D3, unit is in cm. Then we'll label the horizontal axis as our D1, unit is in cm. Then we have D2 values and D3 values. The highest is 16.8 and the highest is 14.7. So we need to make sure that while labeling here, it will cover 16.8. Are you getting it? Now, following all we have said about how to get best scale, appropriate scale, you just follow that pattern. But me, I will not be repeating it often time anymore. So what I will do is that if I say let's here be 2, they didn't ask us to start from the origin or not. So I decided to start from origin because the least numbers are close to what? 0. Now watch. 2, 4, 6, 8, 10, 12. It cannot accommodate this. It cannot accommodate this. If I go by 3, 6, 9, 12, 15, 18, it can accommodate the 2. I can also go by 4, 8, 12, 16, 20, 24. So 3 and 4 can go for this vertical axis. I can write 3, 6, 9, 12, 15, and what? 18. Then for horizontal, the highest is 15. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. And the highest is 15. That means it cannot go by what? 2s. So what I will do, I can say let me go by 3. Okay, 2.5. 2.5. Then 5.0. 5.0. Then 7.5. Then 10.0. Then 12.5. Then 15.0. We use by 2.5. So it can go by 2.5 and this can go by 3. Now we locate our values. 5 against 4.9. 4.9 will be around here. If here is 6 and here is 3, in between there will be 4.5. So then 5 against, okay, 7.5 against 7.4. In between 9 and 6 will be 7.5. So then 10 against 9.8. In between 12 and 9, that would be 10.5. 10.5, and we are looking for 9.8, so before 10.5. Please, this is just a sketch of our graph. Just use this table and plot the graph accurately using your graph sheet. Okay, 12.5 against 12.3. 12.3. Then 15 against 14.7. 15 against 14.7. Okay, we have finished locating our what? Points. Then the next thing is for us to what? Take our what? Line of best fit. Now we have succeeded to plot the line of best fit. Are you getting it? You notice that 2 points fall out on two sides, so we can manage it. We can manage it this way. We can manage it because at least they fall on opposite side. This is your first line of best fit. First line of best fit. We also plot the graph of day 3 against day 1. Day 3 against day 1. 5 against 5.6. 5 against 5.6. That should be somewhere here above this. Then 7.5 against 8.4. 8.4 above this. Then 10 against 11.2 above this. And 12.5 against 14 above this. Then 15 against 16.8. 16.8. Yeah, 15. So 16.8 will be here. Okay. And so we've succeeded to locate these points. So let's also get the line of best fit of it. Okay, we'll call this one L2, right? So in this, one fall this side, one fall this side, just close to the line. Whereas in this one, this fall here, and here fall here. Please be able to note. Let's circle this. This one is for the first one. This one for second one. Okay. All these first one, we are circling them so that we can easily differentiate it from the first one. This first one, we just circled and there are 5. But the second one, we did not what? Circle them. So this is what? So once you are done with this, ensure you indicate your scale. You can write your scale inside the graph, but let them be able to see it. On this vertical axis, we have that. On this axis, we have that 2 cm. 2 cm is that bigger box. The bigger box represents 3 centimeter. Then on D1 axis, we have that 2 cm represents 2.5 centimeter. So you also indicate your scale. Now, next is to get our what? Slope. Next is to get our slope. The first slope, we put our what? Straight line. We put our straight line. We say this is changing D2. Then this one, we also put for this. change in D1. For change in D2, you say it is equals to, this is the highest, this is the highest is before 16.8. Look at this point is 16.8, but the highest is before 16.8. We can just take it 16.5, but when you do it, you get it accurate with your what? Graph sheet. Minus, you take this side is 5.0. For change in D1, it is what? 15.0 minus what? Here, this is 2.5. So we can take care to be about let's take it to be, let's say that this point 2.5, here is 5. Half of this is about 3.75, because this plus this is 7.5. So 3.75. Okay, so before the half, let's say here to be 3. So we now say this minus what? 3.0. But ordinarily, how to get the exact value you have here is that when this is your boss, and here is 2.5, and here is 5, it has what? 10 spaces. 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what you do is 5 minus 2.5, you have it to be 2.5 all over the 10 spaces, 0.25. That means 2.5 plus 0.25, 2.75, the next line, then plus 0.75, 3.0, 3.25, 3.5, 3.75, 4.0, 4.25, 4.5, 4.75. So each of these bars is 0.25. So that is because this next one is 0.25. That is what we, okay, that means 0.25 plus this 2.75. Let's use 2.75. Okay, and so we'll have to compute our what? Slope. Okay, to compute our slope, we will tell them that slope, the first slope, is equal to 16.5 minus 5 all over the second slope, 15.0 minus 2.75. You press it in your calculator. 16.5 minus 5 divided by bracket 15 minus 2.75. You will be having 0.94. 0.94, no unit. No unit because here is centimeter and here is centimeter. They will cancel out. Okay? Then the next is you have gotten your slope. We now said, they said we should multiply the S1 by the value of the mass. That is S1 times 100. We now said, well, for question II, S1 times 100 will be giving you 0.94 times what? 100 gram. And that will be giving you 94 gram. 94 gram. Remember, all we plotted here is just a sketch. Okay, just use your normal graph sheet and do the plotting so that you'll be able to what? Note this. And what do we call this? We will call this the mass of the meter rule. We'll call this the mass of the what? Meter rule. We've been able to get the mass of the meter rule. We'll call this mass of meter rule. So please try to do this plotting well, deduce your values very well, get your slope very well, and be able to get your own slope so that we'll see what you get. Okay, this is just a sketch of it. Then we'll get the slope of the second one. To get the slope of the second one, we have to draw our line. We'll draw it. I just want to take it like this to avoid confusion. This one is change in day 3. Why this is change in day 1? For change in day 3, we'll be having the highest is 14. 14 minus the lowest is 6. Then for day 1, the highest is 12.5. We are taking this line minus where it meets here. Here is about 0.25, 5.5. Here should be about 5.5. 5.5. We say 5.5. We can take it at 5.5, but do the plotting so that you get the accurate answer. So we say slope of the third one, the slope is equal to 14 minus 6 all over 12.5 minus 5.5. What will it give us? We now say that it will give you 14 minus 6 divided by bracket 12.5 minus 5.5. That will be giving you 1.143, no unit, because this is centimeter and this is in centimeter. Now, after you have gotten your S2, just plot your graphs and be able to deduce this slope very well, accurately. We are just using a sketch. Now, they say calculate the volume. How do you get the volume? Volume, our length is length of the meter rule 100 times our L, our W is the width. The width of our meter rule is 2.5 times our thickness 0.5. You use your vernier caliper to measure from here to here and the thickness of the meter rule. So when you do this, you will be having 100 times 2.5 times 0.5, and that will be giving you 125 centimeter cube. So when you do that, you evaluate S2 times S, L times W times T. To evaluate it, I will say 1.143 times 125. What will it give me? It will give me the volume of that meter cube. We'll be having 1.143 times 125. That will be giving me 142.88 cm cube. So this is the volume of the meter cube, of the meter room. This is the volume of it, So how you do this is, when you are done with this graph plotting using your standard graph, this is just a sketch. But as you are looking at how everything is being done here, you can use it to plot your own graph and be able to get your slope as usual. Once you get your slope, say that your slope is this. Multiply it by 100 grams, which is the mass of the steel, to get the mass of the meter rule. That is one. Then get the slope of the second graph. Are you getting it? When you get it, then the volume is the total length of meter rule, which is 100 times the length of the breadth, distance of the breadth, which is 2.5, times the thickness using vernier caliper, we have it to be 0.5. I get you multiply them to get 125. Use 125 to multiply the slope you get for what? L2. And so if you are done with that, that means this is the volume of the meter rule. And when you now divide the mass of the meter rule by volume of the meter rule, you are getting the density of the meter rule, because the title of the graph says to determine the mass and density of the meter rule. So density of the meter rule is equals to mass you got, which you got by L1, slope of L1 times 100. Whatever you get here, you call it your mass, all over the volume. The volume is whatever you get in the slope 2, this L2 slope. Whatever you get there, you multiply it by what? Slope of whatever you get from slope of L2, you multiply it to what? The volume of the meter rule, which is the length times the breadth times the thickness. So all over volume of the meter rule. And so when you compute it, you'll be able to get the density of the meter rule. So that is how to get this experiment done. What we did in the table of value is excellent, but for the graph plotting, because we did not use actual standard graph, we cannot say it is excellent. So use the actual graph and do the plotting. After plotting this, get your slope, multiply it by what? 100 grams to get your mass. Then get the slope of L2, multiply it by the volume, which is the total length times the thickness and times the breadth. Whatever you get, you call it your volume of the meter rule. Then whatever you get finally as your density, please use the comment box below and tell me what you get. Thank you once again for watching today's video. See you next time.